अस्सलाम वालेकुम। आज हमारा लेक्चर नंबर 8 और आज का जो हमारा टॉपिक है दैट्स आल्सो वेरी इंटरेस्टिंग, इंडिपेंडेंस। So what independence means, that two events independent if observing event does not change the probability of observing the event. It simply means that two events are independent. So if one event happens, it's not necessary that it will affect the other one. So that's called the independence. So its definition, we can write it very easily. Events A and B are independent if and only if probability of AB is equal to probability of A into probability of B. So it means that if we take the intersection of two events and then find out the probability, and if it is equal to the individual product of their individual probabilities, then those events will be independent events. So we must be very careful in using the terminology mutually exclusive and independent. Independent and mutually exclusive are not same in probability. But in literature we may have some resemblance in these two words, but in probability we must be careful that these two statements are not the same, because we know that for the mutually exclusive events we know that their probability of intersection of two events must be 0, or the A intersection B should be a null set. But this is not the case for the independence. Here we can see that it must be, if the probability of intersection A intersection B must be equal to the product of their individual probabilities. But there is one exception, and that exception is only when we have probability of A is equal to 0 and or actually either one, or probability of B is 0. Then we can say that they are mutually exclusive or independent. So this is just an exception. So let's solve one simple problem to understand this concept. So this is example 1 point. So I will paste the example or not. So it says that suppose that for the experiment monitoring 3 purchasing decisions in example 1.9 phone smarts company, each outcome sequence of 3 decisions, each either buy or not buy, is equally likely. So we up till here we can see that its sample space would be looking at the 3 purchases, so whether the customer buys or not buys. So sample space will have these 8 elements: by B and B, B and N B, B, N B, N B, N N. Now let's define events B2, that the second customer purchases a phone, and N2, that the second customer does not purchase a phone, are independent. So, and the next it says there are the events B1 and B2 independent. So first we will define these events. So B2, that the second customer buys the phone. So if I mark it with second customer here, and this one, so we'll be having these 4 outcomes in this event: B B B, B B N, N B B, N B N, and N2. So it will be second customer not buying the phone. So this will be using some different color. This one, N second customer, N. So we have these 4 outcomes for this event N2. So it will be B and B, B and N B, and N. So all these outcomes are equally likely. So here we can say that N is 8, so probability of each outcome is 1/8. So probability of B2 is obviously then 4/8, and probability of N2 will be also 4/8, which is 1/2. So to check the independence, we have to take their intersection. Probability of B2 N2. So B2 N2, if we look at them, it is a null set. So it is 0. So it means that probability of B2 N2 is not equal to probability of B2 into probability of N2. So it means that this is very actually these two sets are taken very apparently, that if the second customer buys a phone, obviously it will not buy the phone. And so here we can see, so if the second customer buys, obviously it cannot happen that it will not buy the phone. So these two obviously events are mutually exclusive, but they are not independent, because they are dependent. If the customer buys a phone, obviously it cannot come into this outcome can never happen. So obviously they are dependent on each other. So we can say that B2 and N2 are not independent. Similarly, it says that are the events B1 and B2 independent? So we have to define these events. B1. So B1 means that first customers buys the phone. So I will mark with dark green. So this one, and this one. So it will be BBB, BBN, BNB, BNN. And similarly we can write for B2, means the second customer buys the phone. Sorry, B2, the second customer buys the phone. So we have already written there BBB. I will just write it again, BBN, NBB, NBN. Now again we have to check the independence. Obviously, apparently these two sets are independent, because if the first customer buys a phone, it's not necessary that second customer will buy or it will not buy. So the purchase of first customer is not or the purchase of second customer is not dependent on first customer, and similarly the purchase of first customer is not dependent upon the purchase of second customer. So but again we have to figure out using the relation of independence, probability of B1 into probability of B2. So we know that from here probability of B1 is equal to probability of B2, which is equal to 1 by 2. So probability of B1 intersection B2 we have to find out. So intersection will be BBB, BBN, and that's it. So that probability will be 2 over 8, so which is 1 by 4. So putting in the relation, so 1 by 4 is equal to 1 by 2 into 1 by 2. So it means that events B1 and B2 are independent. Now we can extend this definition of independence to more than 2 events. So let's see for what we will have for the 3 independent events. 3 independent events. So let's A1, A2 and A3 are mutually exclusive, mutually independent if and only if A1 and A2 are independent, B, A2 and A3 are independent, C, A1 and A3 are independent, and D, probability of A1 intersection A2 intersection A3 must be equal to the product of their individual probabilities. So we can see here it will become complex when we have more than 2 events to check for the independence. So for the 3 independent events we have to check each event with another event for the independence. So to understand this, again we will have this simple example 1.23. It says that in an experiment with equiprobable outcomes, the partition partition is S is equal to 1, 2, 3, 4, and probability of each outcome is 1/4 for all S that belongs to S. So question here is that events A1, 1, 3, 4, A2, which is 2, 3, 4, and A3, which is a null set, mutually independent. So we have to show that whether these three sets A1, A2 and A3 are mutually independent or not. So we can first find out the probabilities, because probability of A1 is 3/4, probability of A2 is 3/4, and probability of A3 is 0, because that's a null set. So obviously the probability of A1 intersection A2 intersection A3, which is this intersection, is also a null set, so that will be equal to probability of A1 into probability of A2 into probability of A3. So again this is 0, obviously, because this is 3/4, 3/4, 0. So this is 0. So but here this simple test will not show us that these three events are independent or not. So we have to go for the further analysis. So we have to check for A1 and A2 are independent or not. So we have to find out then A1 intersection A2, means we have to probability find this thing. So A1 intersection A2 is, if we look at A1 and A2, so we will have 3, 4 in common. So probability of A1 intersection A2 is 2/4, which is 1/2, and we know the probability of A1 and A2. So we can see that in the relation here, in this relation, if we put these values, what will it be? So it will be 3/4 into 3/4, so which is not equal. So A1 and A2 are not independent. It means they are dependent on each other. So we don't have to go further for further analysis, because if any of the tests that we have defined in the three independent events definition, so that will be, they will not be the independent events. So by definition, these A1, so A1, A2 and A3 are not independent events. So we can extend this definition for more than two independent events for the for n is greater than 3, or for n independent events. Say if we have n is greater than or equal to 3, A1, A2 up to so on an, so they are mutually independent if and only if So first condition, that all collections of n minus 1 events from a1 a2 up to an are mutually independent. So it means that we have to check for a1 into a1 a2 independence, a1 a3 independence, a1 a4 independence up to a1 an independence, and then again a2 a3 independence, a2 a4 independence, and so on. So we have to check all the independences. And the second, probability of the intersection of the n events should be the product of their individual probabilities. So here we can see that as the number of events are increased for checking the independence, it becomes very cumbersome to find out these numbers. So their obviously their independence will be very difficult to find. But on the other hand, if we know by some means that we have n independent events and we have to find out the probability of any subset of the n events, so that will be just matter of product of their individual probabilities. So let's solve another example to understand this. To understand the independence, so I will copy and paste it here from the book. So this is quiz 1.6. So let's read it out first. Monitor two consecutive packets going through a router. Classify each one as video V if it was sent from YouTube server, or as ordinary data D otherwise. Your observation is a sequence of two letters, either V or D. For example, two video packets corresponds to VV. The two packets are independent and the probability that any one of them is a video packet is 0.8. So probability of video packet is 0.8. And because they are independent, so probability of data packet, individual data packet will be 0.2. Denote the identity of packet I by Ci. If the packet I is a video packet, then Ci is equal to V. We have made an identity. You can say the C is denoted as the identity packet, or otherwise Ci is equal to data packet. Count the number of NV of video packets in the two packets you have observed. So determine whether the following pairs of events are independent. So it means that because we are only checking two packets, so sample space will be very simple. It will be either both of them video, one video and one data, first data, second video, both are data. So by definition, whatever we have given, so we can know because each packets are independent, the two packets are independent. So probability of individual events can be found out very easily. So it means that it will be simply probability of V into probability of V, which is 0.8 into 0.8, which is 0.64. Similarly, probability of Vd, which is probability of V into probability of D, so which is equal to 0.8 into 0.2, which is 0.16. Similarly, probability of dV is 0.16, and probability of both data packets will be probability of D into probability of T is 0.2 into 0.2, which is 0.04. So by having these probabilities, now we can move to the part A of this question. It says that check whether NV is equal to 2 and NV is greater than 1 are independent or not. Use the definition of independence, that probability of NV is equal to 2, NV is greater than equal to 1 must be equal to probability of NV is equal to 2, probability of NV is greater than equal to 1. So let's define these events. NV is equal to 2, NV is equal to 2 can be defined as VV means exactly 2, and NV greater than equal to 1 event can be defined as greater than or equal to 1. So it will be VV, VD, TV. So its probability, obviously, when we know that if one in the intersection, if one event is a subset of the other event, so we will use the probability of simple event, this event. So from here we can find out the probability of NV is equal to 2, which is 0.64, and from here probability of NV is greater than equal to 1 will be equal to the sum of these probabilities. VV is 0.64 plus 0.16 plus 0.16. So this will be I think so 0.96. So probability of now we will put it back into this relation. So as we can see that probability of NV is equal to 2 is NV is equal to 2 event is subset of NV is greater than equal to 1. So intersection will be simply probability of NV is equal to 2, which is equal to probability of NV is equal to 2 into probability of NV is greater than equal to 1. So obviously this is not equal. So it means that probability of NV is equal to 2, NV is greater than equal to 1 is not equal to probability of NV is equal to 2 and probability of NV is greater than equal to 1. So we can say that these two events are not independent. So we can write here not independent. Now going to the second part, it says that NV is greater than 1 and C1 is equal to V. So it's simply probability of NV is means by putting it in a relation first, NV is greater than equal to 1 comma Ci is equal to V. Ci is equal to V means that the first packet is video packet, which is equal to probability of NV is greater than equal to 1 into probability of C1 is equal to V. Now we know the probability of this event, we have already calculated it. It is 0.96 and we have to define this event first, that the first is video, so it will be VV VD, because we have just first is the video call. So probability of if you just write here like this, so probability of this will be sum of these two probabilities, means 0.64 plus 0.16, so it will be 0.80. So in this case probability of NV is greater than equal to 1, C1 is equal to V. So again we can say that C1 is equal to V is subset of NV is greater than equal to 1. So we will have the probability here left with this one. So by putting in this relation, so it will be simple 0.80, which is equal to probability of NV is greater than 1 is 0.96 into 0.8. So obviously not independent. So we can say that these two events are not independent. Now let's see, move to the next part of this problem, C. So in C it says that we have to check for the independence of event C1 is equal to D and C2 is equal to V. So it means that we need to find C1 is equal to D intersection with C2 is equal to V, which is equal to probability of these individual events, product of their individual events, product of probabilities of the individual events. So we will define first this C1 is equal to D, which is probability of first packet is data packet, so dV dt. So their probability will be 0.16 plus 0.04, which is 0.2. Similarly, probability of C2 is equal to V, means second packet is video packet, so it will be VV dV. So it will be then 0.64 plus 0.16, which is 0.8, and probability of their intersection will be probability of dV, which is equal to 0.16. Now putting back these numbers in this relation, so what we will get is 0.16 equals to 0.8 into 0.2. So it means that these two events C1 is equal to D and C2 is equal to V are independent events. Clearly from this question we can understand that if first packet is data packet, second packet can be a video packet, so they are independent as by definition, as by defined in the problem. So they are independent. So it is quite possible that if one is data, the other could be video. So it is not because they are not depending. If one packet is coming as a data packet from the router, the second packet must be a data, or if the first packet is coming as a video packet, the second packet must come as a video packet. So that's why from the question we can also understand that this is these two events are independent events. So I will leave the last part for you people to solve it. So this is the end of the chapter 1. One article remains, that is based on the MATLAB. So I will strongly recommend that you must solve these problems which are given in the book, or at least the examples in the book for the MATLAB, so that you can have a some picture of how you can solve this problem in the MATLAB environment. Best of luck. Assalamu alaikum wa rahmatullahi wa barakatuh.